All right, everybody, welcome to the video here for lesson number 1 on the equation of a line. And actually, in today's lesson, we're going to learn a new form of the equation of a line. And the opening exercise is going to help us kind of develop that. Normally, I'd say try the opening exercise yourself, but we're just going to kind of go through it together because we're reviewing some skills from algebra that you kind of should remember. So the first thing it asks us to do in the opening exercise is to find the slope between these 2 points. So to find slope, there was an equation that we learned, which was subtract the y values and subtract the x values. So if we want to find the slope between these 2 points, I would subtract the second y value, which is 5, minus the first y value, which is 4, the second x value, which is 9, and the first x value, which is 6, which is going to come out to be 1/3. That's my slope. Slope, remember, is rise over run. So if I was to graph these points, I'd go up 1 to the right 3 to get to the next point. The second part says to graph the 2 points and draw a sketch of the line between them. So we could say 6, 4, and 9, 5. And it wants us to sketch this line. So here's my line. I'm going freehand here, just bear with me. If you have a ruler at home, that'd be great. And we'll label this point K. So as to determine the y-intercept, so if I use this idea of slope, I go down 3, and I'm sorry, down 1 to the left 3, I could go backwards here. I find all the points on this line, and I can see that the y-intercept is clearly at 2. So if we know the y-intercept and we know the slope, we can write the equation of the line. So y equals mx plus b. M, remember, is slope. B, remember, is y-intercept. So I could say y is equal to 1/3 x plus 2. Everything that we just did here in this opening exercise is prior knowledge, things you should know already before you came into this class of geometry. So let's see how things change in geometry. So on the next page, it talks about how equations of a line are graphed using slope-intercept form, which we call y equals mx plus b. However, this is not the only form of the equation of a line. Actually, there's an easier one to use. This one looks more difficult, but it's actually way easier. And it's called point-slope form. Point-slope form is an equation of a line that we can use when we know the slope and we know a random point on the graph, which is more common than knowing the y-intercept. The y-intercept is a very specific point. So if we just know a random point on the graph, we can actually write the equation of a line using this new format. And that's what we're going to kind of work on in lesson 1 here. So it says, let's prove that this equation works. So it says, given the equation of line P, y equals 3x minus 2, select the point that's on line P. So go into your graphing calculator, and let's graph 3x minus 2, and go into our table of values. In our table of values, we're going to see a bunch of different points. I just want to pick one of them. So I'm going to select a point that's on this graph. So one of the points on this graph is 5, 13. Again, I'm choosing a random point here. If you really want to, you could use a different point than me if you want. So it says use this point and point slope form to write an equation in the form of line P. So we know from the y equals mx plus b, the slope of this line is 3. And we now know a point, so that's our x1 and our y1. So if we plug into this formula, we could say y minus 13 is equal to 3 times x minus 5. In geometry, this is a perfectly acceptable equation of a line. It's just in this new form called point-slope form. Now, the next part says to rewrite the equation using algebra to show that this is the same exact equation we had of y equals 3x minus 2. So if we do some distributing, I get 3x minus 15 if I do some algebra, I get y equals 3x minus 2. So we could see that they're actually the same. So because of this, we can now use this when we know information about a line, but we don't know the y-intercept, like example 1. So example 1 says determine the equation of line in point-intercept form that passes through the point 2, -5 and has a slope of 1/2. So because it is a random point, not a y-intercept, this is x1 and y1. So I just plug into this new formula. This is not on the reference table. It's something that you would need to know how to do by yourself. So let's plug in what we know. Y minus the y value of -5 is equal to 1/2, that was the slope, x minus 2. Notice I put this -5 in a parenthesis because it's a double negative, and we know that double negatives become positives. And we're done. That's my equation of a line. If I want to, I could put this into the other form of the equation of a line, y equals mx plus b. That might even help me determine what the y-intercept is, but it didn't ask me to do that. It said slope-intercept form, so we're good to go. Let's try another one. So determine equation of a line that passes through the point. So since it's a random point, not a y-intercept, we want to use this new form. It also tells us slope-intercept form. So I'd say y minus y1 equals m times x minus x1. So we'd say y minus the y value, 13, equals -2 times x minus the x value of -3. Again, a parenthesis there because of the double negative. Double negatives we know change to positives. So I have y minus 13 equals -2 times x plus 3. And there you go. That's your equation of a line. Again, you could distribute the -2, move the 13, and put it into the other form, but it asks us for this form, so that's what we'll do. So, it says determine of the equation of the line graphed. So what this equation helps us do is determine the equation of a line when the y-intercept is not so clearly identifiable for us on a graph. For example, on this line, the y-intercept is somewhere between 0 and 1. I just don't know what it is. It's some kind of decimal. But I do see that there are some clear points on this line. So here's one of them. So this point is the point 5, 2. I see another point on this line, which looks to be 9, 3. Now, if I went from one point to the next, the slope here is up 1 to the right 4. So I already know the slope of this line is 1/4. And I know points on this line, so I can write the equation of this line. So I can say y minus either point, so I'm going to use 5, 2, so minus 2 equals 1/4 x minus 5. That's the equation of this line. Then it says to write the above equation in point-slope form. Point-slope form is the fancy way of saying y equals mx plus b. Now, what this is going to show us is that when I do that, I'm going to verify that the y-intercept is a value somewhere between 0 and 1. It should be a decimal or a fraction. So if I take this equation, y minus 2 equals 1/4 times x minus 5. If I distribute, I get y minus 2 is equal to, and I'll use decimals here, so 0.25x minus, if I do 5 times 1/4, I get 1.25. If I then add 2 to both sides, I get a final equation here of y equals 0.25x plus 0.75. I have the same slope, 1/4, all right, that's 1/4 of a slope. And the y-intercept is 0.75. somewhere between 0 and 1. So we're identifying the y-intercept here without having to do a buttload of geometry. We're actually doing more algebra here. This will be the point of the lesson where I'd say, all right, try the next 2 by yourself and see what you get, or next 3 by yourself, or with your partner or something like that. So I'm going to pause the video here, and I'd like you to try numbers 1 and 2. All right, so hopefully you paused the video and you tried 1 and 2. Let's see how you did. So it wants us to write each one of these in point-slope form. Point-slope form is this new form, and then slope-intercept form, right? That's our y equals mx plus b form. So we're asking you to do both. So because we know the slope and we know a random point, I should be able to write this in our new form pretty quickly just by plugging numbers. That's a perfectly acceptable equation of a line. If I do some distributing, right, if I distribute the 3, I'd get 3x minus 18. If I add 7, I get y equals 3x minus 11. There's my other equation. Hopefully you got both of those. Let's see how you did for number 2. So number 2, if we put it in this new form, so we'd say y minus 7 equals the slope of 2/5 times x minus negative 5. Double negative, so we want to change that to a plus. There's an equation. We're good to go. Now, if I distribute the 2/5, I'd get y minus 7 equals 2/5 of x plus 2. 2/5 times 5 is just 2. Type it in your calculator if you don't believe me. Add 7 to both sides, and we get y equals 2/5 of x plus 9. Some of you might be saying at this point, why didn't my algebra teacher show me this? It's so easy. Well, it's not in the algebra curriculum. It's in the geometry curriculum, which is why you're learning it now. So if you didn't get 1 and 2 correct, but now you kind of understand what you're doing, I'm going to have you try 3 and 4. Actually, just 3. Sorry, just 3. So if I pause the video again, just try 3 here. All right, so hopefully you pause the video. Let's see how you did. So I'd say y minus negative 3 is equal to negative 3/2 of x minus 10. Double negative, make that a plus. And there's a perfectly acceptable equation of a line. If we distribute, so we'd have y plus 3 is equal to negative 3/2 x plus, if you do that quick math, it becomes 15. Subtract 3 from both sides, and we get y equals negative 3/2 x plus 12. If you don't know where I got 15 from, use your calculator. Multiply negative 3/2 times negative 10 right in your calculator. It'll tell you positive 15. Now let's do number 4 together because it's different. So number 4 gives us 2 different points, and it wants us to find the equation of the line. Well, before we can find an equation of a line using either method, I first need to know the slope. This goes all the way back to what we did in the opening exercise. So to find slope, we would take the y values and subtract them. So negative 4 minus negative 7. And the x values and subtract them. Positive 4 minus 5. If we clean that up a little bit, or even just type it in the calculator. So if you type it in the calculator, negative 4 minus negative 7, 4 minus 5, you get negative 3. If you're not getting that in your calculator, use parentheses. It'll help. So now that we know the slope and we know points, I just have to pick a point. Doesn't matter which one. So I'll pick this first one. So I'll say y minus that y value is equal to the slope, negative 3, times x minus that x value. If you chose 4 and negative 4, it's going to give you the same answer. It's just going to look a little different. Double negative, let's clean that up. So we get a plus 7. There's your equation in this new form. If you put it in the other form, we would start by distributing and then move the 7 to the other side, and we'd get y equals negative 3x plus whatever that comes out to be, 8. There you go. All right, so pause the video and try number 5. All right, so let's see how you did. So we'll come back. Let's see if you did this right. So first find the slope. So the slope we're going to find by subtracting the y values and subtracting the x values. So the slope in this case is going to become negative 1. Let me just check that. I'm pretty sure that's right, though. So if I do 1 minus 7 and 2 minus negative 4, yeah, we get negative 1. So then we could say, pick a point. I'm going to pick this one. So I'll say y minus 1 equals negative 1 times x minus 2. Perfectly acceptable equation. If you chose the other point, you would have got y minus 7 equals negative 1 times x plus 4. It looks totally different, but it's actually the same, I promise. Now, if we do some distributing, we'd have y minus 1 equals negative x plus 2, add 1 to the other side, and we get our final equation of negative x plus 3. We would have got the same answer if you used the other point. All right, so at this point, we're going to pause the video, or you could come back to the video because I'm going to put the homework and the notes all in one big video here today. So don't watch the video until you've actually attempted the homework questions, please. It is important just to make sure that you understand what you're doing. Okay, use your notes, go back and rewatch the notes part of the video if you're confused about a question, and then you can rewatch the homework video to see if you're doing it right or not. All right, so welcome to the homework part of the video. Hopefully you tried these 3 questions on your own before you came here. So the first question says, determine the equation of a line that has a slope of negative 1/4 and passes through the point negative 4, negative 5. Since it's a point, not a y-intercept, we definitely want to use this new form of point-slope form. So we would say y minus negative 5 is equal to negative 1/4 x minus negative 4, double negative there. So I have y plus 5 is equal to negative 1/4 times x plus 4. This is perfectly acceptable and done. If you went one step further and solved it for y equals mx plus b, which you could do, you'd wind up getting y plus 5 is equal to 1/4 x plus 1, subtract the 5, and you wind up getting y equals 1/4 x minus 4. Not necessary, but if you did it, you could check your answer there. Number 2 says determine the equation of a line that passes through those 2 points. So first we have to find the slope. To write an equation of a line, we have to have slope. So if I subtract the y values, negative 1 minus negative 2 divided by negative 7 minus negative 9. So this slope is going to come out to be whatever the calculator tells me here. So type it in if you need to. Negative 1 minus negative 2 and negative 7 minus negative 9. That gives me 1/2. Pick a point. It doesn't matter which point. So I'll pick the first one. So I'll say y minus negative 2 is equal to 1/2 times x minus negative 9. Let's clean up those double negatives. So we have a plus 2 and a plus 9. Again, perfectly acceptable equation of a line. If you went one step further, you would get y plus 2 is equal to 1/2 x plus 4.5. I like fractions, but a lot of you like decimals, so I'll use a decimal there. Subtract 2, and we get y is equal to 1/2 of x plus 2.5. Either way, no matter which point you used, you'd wind up getting that same equation. Number 3 gives us the actual line itself. We notice that the y-intercept is not going to be a nice point, so using this new form of point-slope form is going to be way easier for us here. So the first thing we have to identify is 2 points on this line so I can figure out what the slope is going to be. So I have a point here, and it looks like I have another point here. So I have the point 3, negative 2, and I have the point 7, negative 5. So the slope of this line, if I do rise over run, it's a negative slope line, so it's going to be negative, I know that. The y values change by 3, the x values change by 4. So if I just pick one of these 2 points, it doesn't matter which one, so I'll pick the first one. I could say y minus negative 2 is equal to negative 3 over 4, x minus 3. Clean up the double negative, and we get an equation of a line. Now this question did actually ask us to find both forms of the equation of a line, so that's one of the answers. If I distribute the 3/4, I would have y plus 2 is equal to negative 3/4 x, double negative, that's going to make this a plus, and that's going to come out to be 9 over 4, or 2.25, whatever you did there. If you subtract 2, you're going to get y is equal to negative 3 over 4x plus 1 over 4. If you use decimals there, totally fine. It would have just been 0.25. Hopefully this video helped, and hopefully I see you soon. All right, so keep watching the video, stay up with the work, and you'll be all good. See you soon.